Okay, so I'm going to begin. I'm going to start with the normal distribution part. Determine whether the graph can represent a normal curve. If it cannot, explain why. As you notice, the curve starts at 0. The normal curve has negative values and positive values, and it looks like it's skewed to the right, so that does not represent a normal curve. Number 2. The weight of 2-year-old hyraxes is known to be normally distributed with a mean of 2,200 grams and a standard deviation of 365. Draw the normal curve. Let me show you how you can do that using StatCrunch. So you go to calculators, normal, go, mean is 2,200, standard deviation is 365. Compute, and there you go. That's the normal curve. The mean is 2,600, is right in the center, and you add 365, add 365, add 365, and same thing on the other side. Next question: shade the region that represent a proportion of hyraxes who weighted more than 2,930 grams. More than 2,930, change this one to more and put 2,930. Compute. Here you go. That's the region that is more than 2,930. Okay, number 3, the SAT is an exam used by colleges and universities to evaluate undergraduate applications. The test scores are normally distributed with a mean of 1475, standard deviation 308. The test scores for 4 students are given. Find the z-scores for each value and determine whether they are unusual. Okay, here's how we do this one. So the mean is 1475, standard deviation 308. These are the values. The z is the value minus mean divided by standard deviation. For x equals 1930, you put the value 1930 minus 1475. And then whatever you get, you divide by 308, you get 1.48. A z-score will be unusual if it is more than 2 and less than -2, so this is not unusual. You do the same thing for x equals 1340, it's -0.44, that's not unusual. But for x equals 2150, the z-score is 2.19, which is larger than 2, that's unusual. And for x equals 1450, z is -0.08, that's not unusual. So next question is to find the area under the normal curve between -0.45 and 2.11. So you go to the normal calculator, and here it is. The answer is 0.6562. Okay, next question. Find the area under the standard normal curve to the left of z equal 1.5. So here's how you do it. So to the left, I have to go to standard, and to the left means less than. Remember 0, 1, you're working with z, and just put 1.5 right here. The answer is 0.9332 if you round to 4 decimal places. Number 6, find the area under the standard normal curve to the left of z. Find the area under the normal curve to the left of z equal 1.25. Okay, it's done the same way. All I need to change, just change 1.5 to 1.25. And the answer is 0.8944. Number 7, find the probability of z between 0 and 2.25. So we go to between and put 0 and change this one to 2.25. Hit compute, and here's the answer, 4878. Number 8, the distribution level of teenage boys is approximate of cholesterol in teenage boys approximately normal with mean 170 and standard deviation 30. Levels above 200 warrant attention. If 95 teenage boys are examined, how many would you expect to have a cholesterol greater than 225? before we do figure out how many, we need to find the probability that a teenage boy will have a cholesterol level of more than 225. So here's how we do that. We need to change the mean to 170, the standard deviation to 30, go back to standard, more than, you change the sign to more than right here, 200. Okay. Actually, it's 225. Compute. So this is the probability, which is 0.0338. What you do, you just take 95 and multiply by 0.0338 to get the number of boys out of the group of 95 who will have cholesterol level higher than 25. Next question, find the area under the standard normal curve to the right of z equals to 1. So we'll go to the normal calculator again. So z, back to z, 0, 1. Have to go back to 0 and 1. And to the right greater. And to the right of z equal 1, right here. Here it is, 1587. This is the probability of z greater than 1. Find the area under the standard normal curve between z equal negative 1.5 and 2.5. Here's how you do it. So you go to between again. Negative 1.5 right here. 2.5 there. Compute. And the answer is 0.9270. Okay. Number 11. Find the area under the standard normal curve that lies between 0.3 and 1.4. Here's how you do it. So change to 0.3 right here. And 1.4. It's 0.3013. So again, number 12, assume the variable x is normally distributed mean of 60 and standard deviation of 16. Compute the probability of x less than 80. If I go to StatCrunch, change the mean to 16, standard deviation to mean to 60, standard deviation 16, put probability of x less than 80, hit compute. You get the answer, which is 0.8944. Number 13, a physical fitness association is included in the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with a mean of 450 and a standard deviation of 50. What's the probability a randomly selected boy in secondary school can run the mile in less than 335? Okay. Go to StatCrunch. 450. 50, and we need, that's 50 right here. We need the probability of x less than 335. That's it. 0.0107. And if you want to change it to a percent, it will be 1.07%. Okay. Next question. The length of time it takes college students to find parking spot in the library parking lot follow a normal distribution with a mean of 6.5 and a standard deviation of 1. What's the probability that a randomly selected college students will take between 5 minutes and 7.5 minutes to find a parking spot? Remember, the mean is 6.5 and the standard deviation is 1. So mean is 6.5. Standard deviation is 1, and in between we need the probability that the students will take between 5.5 minutes and 7 minutes to find a parking spot, which is 0.5328. Okay, I made a mistake here. The question is not 5.55 minutes. So I'll change that 5. And the other one was 7.5 minutes. Okay. So let's switch the 7 point, that should be 7.5. It's gonna change the answer 0.7745. But the idea is exactly the same. A firm believes that the internal rate of return for its proposed investment can best be described by a normal distribution with the mean of 36% and a standard deviation of 3%. What's the probability that the internal rate of return for the investment exceeds 42%? Okay, you can change them to decimals if you want, or you can use the numbers without the percent as long as you are consistent. So the mean is 36, the standard deviation is 3, and we need exceeds means greater than, guys. So just go to StatCrunch, 36, 3, and we said we need a standard again, exceeds means greater than 42. It's 0.0228. And if you change the 36% to a decimal, it would be 0.36. If you change 3% to a decimal, it would be 0.03. If you change 42% to a decimal, it would be 0.42. You should get the same answer. It is the same answer. Okay. Number 16, find the z-score for which the area under the standard normal curve to its left is 0.04. So he's given us the area to the left and he wants the z-score. Okay, here's how we do that. So we'll go back to 0 and 1 since it's about z. Area to the left, you have to use a less sign. And this is where you put the area, guys, right here in the right box. So I'm going to put 0.04. You're going to see the z-score show right here. So it's negative 1.75. That's the answer for the z-score. Next question. Find the z-score for which the area to its right is 0.07. Okay, so we change this one to greater. And we put 0.07 right here. And it's 1.48. Next question. Determine the two z-scores that separates the middle 87.4% of the distribution from the area in the tails of the standard normal distribution. Okay, 87.4. So you go to between, you just put 0.874 here, and that will give you the middle. You're gonna see that this is one z is negative 1.53 and the other z is 1.53 right here. Next question. Assume that the random variable x is normally distributed with a mean of 50 and standard deviation of 12. Find the 24th percentile. A percentile is an area to the left, so he's given you the area to the left to be 0.24. But remember, he gave me a value for the mean and standard deviation. I can't use 0.1. Mean is 50 and the standard deviation is 12. So mean is 50. Standard deviation is 12. You go to standard, we need to go less, and it's 0. What was it? Which percentile? 24 or 34? 24th percentile. So just put 0.24 right here. So x is 41.52. What about if I add, he says first quartile, you use 0.25. If he is third quartile, you use 0.75, and so on and so forth. Next question. 20. A physical fitness association is included the mile run in its secondary school fitness. The time for this event for boys in secondary is known to possess a normal distribution with mean of 440 and standard deviation of 50. The fitness association wants to recognize the fastest 10% of the boys with certificate of recognition. What time would the boys need to beat in order to earn a certificate of recognition from the fitness? Remember, this is a race, and fastest doesn't mean an area to the right. It means an area to the left, because the less the time, the better. The less the time you take to do the race, to do the run, is the better. So the 10% is going to be an area to the left. Okay, and let me show you how you do that. So 440, 50, and we're going to go the 0.10 right here. So the boys who finish in 375.9 seconds or less are the ones who get recognized and will get the certificate. Number 21. Assume that the salaries of elementary school teachers in the United States are normally distributed with a mean of 37,000 and a standard deviation of 5,000. What's the cutoff salary for teacher in the bottom 10%? Bottom 10%, yes, it is an area to the left. So here's how you set it up using StatCrunch. You put the mean, 37,000, standard deviation 5,000, less than, and you put 10,000 right here, and you hit compute. Oh, I put 50,000. That was a mistake here. Let me change this one. It's not allowing me to select. Just 1 second. Okay, so let me put 0.01 here. And now it looks right. So teachers who earn $30,592 or less are in the bottom 10%. So again, for this question, determine the mean of x bar and sigma of x bar for the given parameters. He gives you the mean, he gives you standard deviation, he gives you the sample size. According to the central limit theorem, the mean of x bar is the same as the mean, so the mean will be 28. And the standard deviation of x bar will be original standard deviation divided by square root of 22. So 8 divided by square root of 22, which is 1.71. Next question. This is x bar, guys. There should be a bar above this one right here. So to find the mean of x bar, it shows it's the one in the center, 8. And the standard deviation is the difference between this value and the next one, which is 0.04. So mean of x bar is 8 and sigma of x bar is 0.04. Next question. The number of violent crimes committed in a day possess a distribution with a mean of 2.2 crimes per day and standard deviation of 6 crimes per day. A random sample of 100 days was observed and the mean number of crime of the sample was calculated. Describe the sampling distribution of the sample mean. According to the central limit theorem, the distribution of the sample means is going to be approximately normal as well. The mean will be the same as the original mean, which is 2.2, but the standard deviation will be 6 divided by square root of 100, which is 0.6. 6 divided by square root of 100 is 10. 6 divided by 10 will be 0.6. And let me show you how would that look under the normal curve. So 2.2 right here, 0.6 there, and let me just show you right. But we have to put something here. So look, this is the 2.2, that's the mean. And you keep adding 0.6, 0.6, 0.6, subtract 0.6, subtract 0.6, and if I do that right here, see, 2.2, 2.8, 3.4, 1.6, and so on and so forth. So that's how you can describe the sample distribution of the sample means. 26. The amount of time employees of a telecommunications company have worked for the company are normally distributed with the mean of 5.4, standard deviation 2.1. Random samples of size 12 are drawn from the population and the mean of each sample is determined. The question is, determine Describe the sampling distribution of the sample means. It's the same question. So the mean of X bar will be the same as the original mean, which is 5.4. The standard deviation will be 2.1 divided by square root of 12. And let me tell you what that is. So the standard deviation will be 0.61. And just to show you the curve, let me show you the curve right there. So we have 5.4 and 0.61. It would be, and if just click 68, 95, 99.7% ticks, it will show you the distribution. This is the mean in the center, and it will add one standard deviation, one standard deviation, one standard, and it will subtract one standard deviation if you click 68, 95, 99.7 tick marks. So it will do it by standard deviation, and that's what the curve looks like. 27. Assume the salaries of elementary school teachers in the United States are normally distributed with a mean of 32,000 and standard deviation of 3,000. If 100 teachers are randomly selected, find the probability that their mean salary is greater than 32,500. Remember, the question is not about X here, it's about the sample mean. So this is a probability of X bar greater than 32,500. The mean will remain the mean, so it's going to be 32,000, but the standard deviation changes. So the new standard deviation, which is called the standard error of the mean, will be 3,000 divided by square root of 100. Square root of 100, guys, is 10. So 3,000 divided by 10 is 300. So when you go to StatCrunch, you cannot use 3,000. You must use 300. So let's go and do it in StatCrunch. So 32,000 right here. 300. You want to use those tick marks, that's fine. And we need a probability of X bar less than 32,500. There you go. It's 0.9522. And that should be, if you're showing your work, instead of X, you should put X bar above. You should put a bar above the X. Okay. Number 28. The average score of all golfers of a particular course has a mean of 75 and a standard deviation of 4.5. Suppose 81 golfers played the course today. So N is 81. So the question is not going to be about X, it's going to be about X bar. Find the probability that the average score of the 81 golfers exceed 76. Exceed means more than. So we need to find this answer, probability of X bar bigger than 76. So once it is about X bar, the standard deviation changes. And the standard deviation of the sample means is going to be the original standard deviation, which is 4.5 divided by square root of 81, which is 0.5. So you cannot use 4.5, you have to use 0.5 now. And what's the mean? 75. The standard deviation is 0.5, and we need a probability of X bar greater than 76. So let's go to StatCrunch. Change this one to 75. 0.5. Exceeds means greater than 76. It's right here. And you see when this is 75, the center, and 75.5, add a 0.5, add a 0.5, add a 0.5 will be 3 standard deviations. Subtract 0.5, you subtract 0.5, subtract 0.5. You will go between a z-score of 3 and a z-score of -3, and the answer is 0.228. Okay. 29. The amount of money collected by a snack bar at a large university has been recorded daily for the past 5 years. Records indicate that the mean daily amount collected is 4,000 and standard deviation is 450. The distribution is skewed to the right due to several high-volume days, including football game days. Suppose 100 days were randomly selected from the 5 years, and the average amount collected from those days were recorded. Which of the following describe the distribution of the sample mean? So the question is, describe the sampling distribution. You know, the distribution of the sample means, if you remember from the applet, it's going to look normal. So it's going to be normal. The mean will be the same as the mean of the original one. So the mean will be 4,000, but the standard deviation will change, guys. The standard deviation of the sample means will be the original standard deviation, which is 450 divided by square root of 100. What is a square root of 100? It's 10. What's 450 divided by 10? 45. So, in summary, the sampling distribution will be approximately normal with a mean of 4,000 and a standard deviation of 45. Theory. The length of pregnancy are normally distributed with a mean of 264 and a standard deviation of 15 days. If 36 women are randomly selected, find the probability that they have a mean pregnancy between 264 and 266. Since the question is about the sample, guys, you cannot use the original standard deviation. So the new standard deviation is going to be 15 divided by square root of 36, which is 15 divided by 6, which is 2.5. So I can't use 15, I have to use 2.5. The mean will remain the mean, 264. So here's how you do it in StatCrunch. We're going to go to 64. Standard deviation again is 2.5. And we need the probability of X bar between 264 and 266. And again, if you're showing your work, guys, here, you cannot put X. You need to put X with the bar on top of it. And the answer is 0.2881. That concludes the review of the normal distribution chapter. So I'm going to provide this in a video by itself. And then the second video will be about confidence intervals.